or good afternoon, wherever you may be. So the topic for today is Autoscaling Masterclass, the new capacity plan. I am a solutions architect and I cover the Southeast Asia region for Amazon Web Services. And for today, we're going to cover a whole host of topics, including a small introduction into Amazon EC2, types of scaling on the platform. I'm going to introduce autoscaling after that, and then talk about the terminology that we use with autoscaling as well. We're going to cover a few best practices, and then at the end, we're going to have a small demo using the Amazon Web Services console. To start with, Amazon EC2 is a web service that provides resizable compute capacity in the cloud. It's designed to make web-scale cloud computing easier for users and developers. EC2 gives you the ability to run both Windows or Linux distributions, including Ubuntu, CentOS, Red Hat Linux, and Windows Server 2003, all the way through to 2012 R2. You also get to choose from a wide variety of instance sizes. And instances are basically virtual servers in the cloud. Instances can be launched with what we call an Amazon machine image. Basically, an Amazon machine image provides the information required to launch the instance. You specify an AMI whenever you launch it, and you can launch as many instances as you want from that one AMI. You have full administrative control of the instances and can secure the instances via firewalls we call security groups and network access control lists. So let's talk a little bit about the types of scaling in general. So to start with, the first and most common way of looking at it is vertical scaling. To scale vertically or to scale up means to add resources to single nodes in a system. Typically, this involves the addition of CPU or memory to a single computer. And taking advantage of such resources can also be called scaling up. So you could look at increasing the amount of Apache daemon processes you're running currently as well. In terms of Amazon, that could mean moving from an M3 medium instance through to a C3 2 extra large instance, all the way up to an R3 8 extra large instance, which is one of our largest instances on the platform. The other way we look at scaling is horizontal scaling. To scale horizontally really means to scale out or to add more nodes or instances to a system. Rather than scaling up to handle the increased load, we can add more instances to increase the total compute or memory available to a given application or process. Another thing that you could do is add an elastic load balancer to handle web traffic for multiple web servers. This helps distribute the load as well. So as you saw in the animation that just went by, we actually just added M3 mediums rather than increase the size of that one particular instance. And then you could also look from a horizontal scaling perspective to scaling back down using that same terminology. So if you were to go down the path of vertical scaling, at some point in time, you're going to say, we're going to need a bigger box. But in saying that, though, scaling the one EC2 instance we have to a larger instance is one of the simplest approaches to start with. There are a lot of different AWS instance types to go with, depending upon your workload. Some have high I/O, some have more CPU or high CPU, some have more memory available to them. Or if you need high storage or local storage, that's available as well. You can also make use of EBS optimized instances and provisioned IOPS to help scale the storage for the instance quite a bit. Eventually, though, we're going to hit an endpoint, and this is really what we see traditionally in IT usage patterns as well. So traditionally, compute resources are bought to handle peak measurable or estimated loads. In this slide, the blue lines represent the compute needs of your company or workload. The gray line is the traditional method of procuring compute capacity. The x-axis is time, and the y-axis is capacity. So if you look at all of these different usage patterns, I'll go through each of them one by one. So on and off really means you have something that comes online for a little while and then is off completely. But if you look at the gray line, which is what is procured, you've bought more than what you need at one point in time. From a fast growth perspective, this looks at applications that are growing rapidly within an organization, where you understand the growth is going to be quite exponential, so you look to stagger the purchases of your compute needs. Variable peaks is really what we see for a lot of startups, for a lot of hot platforms where you don't understand exactly how many people are going to come onto the platform. You kind of hit a median point and say, this is how much I need. And the last one is predictable peaks. This is really useful when you have some kind of a reporting platform at the end of the year or at the end of the month where you need to churn out reports. This is usually what we see as far as that platform is concerned. With all of these different patterns, there are two problems. There can be a significant amount of wasted compute resources, the capacity is available for you, but you may not need it. And in the variable peaks usage pattern, you may have an insufficient capacity issue as well. And that basically means you can't serve customers, which means it's a bad customer experience, and we never want to see that. So this is where autoscaling can really play a big part and can help you with your platform. So autoscaling allows you to automatically resize your compute clusters based upon your demand. You can define a minimum and maximum number of instances. You can define when to scale out and in as well. And you can use metrics collected to drive the scaling itself. And we'll talk more about each of these individual pieces. You can run autoscaling on on-demand instances as well as spot instance types. And I think best of all, it's free. We don't charge you anything extra for this particular service. All you would pay for is the actual compute capacity that you consume. So there's a small animation here. So there are multiple ways of actually calling autoscaling. So the first one is obviously usage metrics from the autoscaling group. They go to CloudWatch, and then CloudWatch would actually send a scaling instruction back to the autoscaling group to scale out, and then back in once the load goes away. That's not the only way you can actually scale out. You could also use, as an example, queue metrics. So if you have things that are lining up in a queue, you can send those to CloudWatch, which could then send the scaling instructions to scale out, and then back down to 0 if you don't have anything in the queue post that. So let's bring it back to the traditional IT patterns. Let's see what would happen if we would actually do this with autoscaling. So you have the ability and flexibility with autoscaling to use the resources only when necessary and ensure that unexpected peaks are handled as well. So you have full control of your resources, and you get to match the curves of your resources based upon your usage patterns. So let's dive a little bit deeper into autoscaling now. Let's go over some of the terms we commonly talk about with autoscaling. So I'm going to go over each of these very in depth now. So autoscaling groups, launch configurations, scaling plans, CloudWatch alarms, elastic load balancer, instance life cycles, and instance metadata and user data. All right. So the first thing that we have is an autoscaling group, which is really a core component here. So all the EC2 instances that are within autoscaling are categorized into an autoscaling group, right? You can create groups by defining the minimum, the maximum, and optionally the desired number of running EC2 instances as well. The second and one of the most important pieces is to define a launch configuration. A launch configuration basically is what is used by the autoscaling group to launch the EC2 instances. You create the launch configuration by providing information about the image you want to use, about the instance size, about more information about where you want to launch it, where the availability zones are, etc., etc. And we'll go through that in the demo. A scaling plan is the third part to this triumvirate. The scaling plan tells autoscaling when and how to scale. So you can create a scaling plan based upon the occurrence of specific conditions. So that's really towards dynamic scaling. A good example of that would be the variable peaks. So if you want to match to a certain CPU load or to a certain amount of users on a platform, you could use the scaling plan to scale out based upon that. Or if you understand the schedule, so looking at the periodic periods or the on and off types of traditional IT use cases, you could define a schedule and scale based upon that as well. All right, so talking about CloudWatch now, retrieving resource metrics is a very important piece, and the way we do that on Amazon Web Services is we use CloudWatch. CloudWatch is basically a web service that enables you to monitor and manage all the metrics that you want to. You can configure alarm actions based upon data from those metrics. One very important piece to understand about CloudWatch is that it has an API where you can send whichever metric you'd like to that platform. So if you want to send custom metrics about your application, you can do so, and then you can raise CloudWatch alarms based upon those metrics. So a CloudWatch alarm is basically an object that would monitor a single metric over a specific period, right? If you look at what a metric is, it's basically the variable that you want to monitor. A good example of that is CPU usage or incoming network traffic. The alarm changes its state when the value of that metric breaches a defined range and maintains the change for a specified number of periods. What that basically means is, let's use an example of CPU usage. So if we state that we have an alarm that is set for 80% CPU utilization, if your average CPU utilization over a 5-minute period stays at above 80%, at that point the alarm is breached, and then you can take an event to follow on from there for autoscaling or whatever you want to do from that point. So it's very important to actually plan your autoscaling group. You got to understand a whole host of things before you actually build it out and make sure that it's running the way you want it to run. The first thing you got to look for is how long does it actually take for you to launch and configure a server. So using AMIs, you can obviously launch your instance, but it may not come up within a few seconds. It's going to take a few minutes for it to actually come online. So you need to take that into account when you're creating your autoscaling group. If you have an extremely aggressive scaling policy, or if you have an extremely aggressive website which scales fast, you may want to set your metrics a little lower to adjust for that additional time it takes to launch the servers. The next piece is extremely important as well. What metrics have the most relevance to your application's performance? Certain applications will have more CPU utilization versus memory utilization. But is the CPU utilization the right metric to choose because it's always at 100%? Sometimes that's not the case because the alarms will just keep breaching regardless of how much load is on the platform. So you want to be sure about which metric you use. The next one is what existing resources such as EC2 instances or AMIs you might want to use as part of your autoscaling group. So if you've already pre-configured certain instances to run in a certain way, you can add that to your autoscaling group at any given point in time. The next one is how many availability zones you want to use for your autoscaling group. These are things that you have to define within the autoscaling group so you understand that you can provide for a high availability as well with this platform. And the last one is the role you want autoscaling to play within your application. Do you want autoscaling to use scaling to increase or decrease capacity, or do you want to use it solely to ensure that a specific number of servers are always running? Keep in mind that autoscaling groups can be used to perform both functions simultaneously. So you could have a highly available platform as well as increase or decrease based upon demand as well. The next bit that is important here is load balancing your autoscaling group. So you want to distribute incoming web traffic automatically. This is something that's important because as you have more and more servers, you want to have a single point of entry for your application. You don't want to have users come in and then have to choose which web server they go to. So elastic load balancing actually handles that off for you very well, and it plays well with autoscaling as well. You can define an elastic load balancer within your autoscaling policies. The Elastic Load Balancer also sends data about your load balancers and EC2 instances to CloudWatch. So it actually plays a very important part within your scaling policies. You can use Elastic Load Balancing metrics to scale your application. So it does not need to be EC2 metrics. It could be the amount of bandwidth that's being consumed by the Elastic Load Balancer, or it could be any other metric that you want. If you're seeing 503 errors at the back end, that could be a call to actually scale out as well. Another very important piece here is using connection draining to wait for the in-flight request to complete. So what that is it's actually a feature of autoscaling and elastic load balancing, where basically if you do have an instance that has been scaled in and it's in the process of being terminated, you want any connections that are currently established to that particular server to complete before it's brought out of the loop. Now, what we have is a feature where basically if it's set to a state which is terminating, no new connections will be sent to that particular instance, but all currently in-flight requests will be completed, and only then will the EC2 instance be shut down. Okay, so let's consider the following scenario. You have a web application running in AWS. To make sure that the application always has the resources it needs to meet traffic demands, you create an autoscaling group. To help make sure that the autoscaling group for the application tier has the appropriate amount of resources available, you create a CloudWatch alarm to occur whenever the CPU utilization metric for the EC2 instances exceeds 80%. When the alarm occurs, autoscaling launches and configures another instance to join the application tier. These instances use a configuration script to install and configure software before the instance is put into service. As a result, it takes around 2 to 3 minutes from the time the instance launches to when it is in service. Now, let's look at when a spike in traffic occurs. This causes the CloudWatch alarm to fire. When it does, autoscaling launches an instance to help handle the increase in demand. However, there may be a problem because the instance takes a couple of minutes to launch. During that time, the CloudWatch alarm continues to fire, resulting in autoscaling launching more instances each time the alarm goes off. This is where cooldown periods come into effect. With a cooldown period in place, autoscaling launches an instance and then suspends any scaling activity until a specific amount of time elapses. By default, the amount of time is set to 300 seconds or 5 minutes. This way, the newly launched instances has time to start handling application traffic, and then you can have a cooldown period for that to expire. So after the cooldown period expires, scaling actions resume for the autoscaling group. If the CloudWatch alarm is still occurring, autoscaling launches another instance and the cooldown period takes effect again. If, however, the additional instance was enough to bring up the bring the CPU utilization back down, then the groups remain the same at its current size and doesn't change. So basically, we don't have to worry about any additional resources coming online if it gets back to a normal state within the cooldown period. As I mentioned in the example, an autoscaling cooldown period helps to ensure you don't launch or terminate more resources than your application needs. Autoscaling supports 2 types of cooldown periods: a default cooldown period, which we mentioned was 300 seconds, and a scaling specific cooldown period. So you can define your own. So if you want something to be extremely aggressive and you think 5 minutes is too long, you can define it to a much shorter period as well. Okay. All right, so let's talk a little bit about autoscaling life cycles. So like Amazon EC2 instances, which are launched manually, instances in an autoscaling group follow a specific path or life cycle. For autoscaling instances, this life cycle starts when you create a new autoscaling group or when a scale-out event occurs. At that point, a new instance launches and is put into service by the autoscaling group. The life cycle ends when a corresponding scale-in event occurs, at which point the autoscaling group detaches the instance and terminates it. Now, this is really important to understand because we've recently announced something we call lifecycle hooks, right? Each EC2 instance in an autoscaling group goes through a defined set of states and transitions during its lifetime. In response to a scale-out event, instances are launched, attached to the group, and become operational. Later, in response to the scaling event, like I said, they are removed from the group and then terminated. After it has launched, though, but before it's attached to the group, we've added something known as lifecycle hooks. Autoscaling calls this state pending. So this is your opportunity to perform any initialization operations you may want to have. So if you need to install or configure software, create, format, and attach EBS volumes, connect to the instance to message queues, and so forth, you have that ability with a lifecycle hook, right? The same thing is there when you detach it from a group, but before it has been fully terminated. We call this state terminating, or Autoscaling calls this state terminating. You can do any additional work that is needed to fully decommission the instance. You can capture a final snapshot of any work in progress. You can move log files to long-term storage, or hold a malfunctioning instance off to the side for debugging. You can do that with a lifecycle hook, right? So you can configure a set of lifecycle actions for each of your autoscaling groups. Messages can be sent to a notification target for each time the instance enters a pending or terminating state, and you can automate this entire process with an application, and then you can define how you handle it from there on in. Talking about initialization of instances, that's where I'd like to introduce you to something we call bootstrapping. So bootstrapping is the ability for you to perform an action on an instance on launch. With lifecycle hooks, you have the ability to bootstrap your instance before they get added to the pool of resources being used. And bootstrapping actions can honestly be anything you want them to be. And here are just some examples. So you can install the latest software, you could copy data from S3, you could register with DNS, you could start services, update packages, reboot, open port 80, register with the load balancer, and mount devices. They're all available to you. With AWS, we have several tools to help you bootstrap. These include, but aren't necessarily limited to, Bash and PowerShell scripts, as well as configuration tools such as Chef and Puppet. We also have another product known as Amazon OpsWorks. Amazon OpsWorks uses Chef to basically handle configuration management and deployment as well. To maximize use of bootstrapping with AWS, you should know and understand what we call metadata and user data of the EC2 instance. Every EC2 instance has access to local metadata and user data services. Metadata is basically information about that specific instance. It's accessible only from within the instance, and it's a common URL for all instances, which is http://169.254.169.254/latest/meta-data. So if you go to any EC2 instance right now, and if you wanted to curl this particular URL, you would get the metadata about that particular instance. And in the demo, I'm actually going to show you how we leverage that data and display it on a page. Right. So your scripts can use this metadata to get a lot of useful information about the instance. The metadata server also stores IAM role credentials, right? So you can get information about the host name, the AMI ID, the instance ID, the public and private DNS, the availability zone of the instance, the region of the instance, any additional information that is specific to that particular instance is available to you as well. The EC2 instance can also include user data. Now these are instructions that a script on the instance can pass and use to configure the system. Do note that user data has a maximum size of 16 kilobytes. And like I mentioned, you need a script on the EC2 instance so that can be passed by user data, right? Most EC2 instances include Cloudlnit, which can actually pass your user data and run its instructions. To use Cloudlnit on Linux machines, you start your user data with a hash bang or a hash exclamation mark and then call whatever you want to call. With Windows machines, you would have a script bracket to start with and then script to close it off as well. And technically EC2 config, which is actually installed on all EC2 Windows machines, handles this, not Cloudlnit, but the result is basically the same as well. And I said most EC2 instances use Cloudlnit or EC2 config. Excuse me. Let's get more specific. Cloudlnit is available on Amazon Linux, Ubuntu, and Red Hat Enterprise Linux AMIs. EC2 config is available on all Windows Server AMIs. Either one of these may be available for other distributions. However, you'd have to install it via a package repo or the actual source code. So you could have this installed into CentOS or whatever else that you want to use. It's available. Here's a quick example of user data that installs Apache, it installs MySQL, and then it attaches an elastic IP address to that particular instance. So if you look, this would actually be installed as a user data script. You can see that we're doing a hash bang /bin/bash to call up the bash script. We're then doing a yum install of HTTPD and MySQL Server. The next bit we're doing is attaching the elastic IP address. So we're calling the EC2 command to associate an address. We're then defining what the address is or which IP address we want to assign to it. And then what we're actually doing is we're doing a -i, which is to call the instance ID you want to associate the address with, which will call the local instance ID. So you can actually do this on the fly for all instances if you knew which IP address you wanted to assign to it. What that basically looks like is when there's an instance request, you pass user data. The user data will call the metadata service, and then using the metadata service, they would launch the instance with that data. For Amazon Windows EC2 config, it's fairly straightforward as well. You can call a script. So in this example, we're just doing a directory, and then we're passing that log to a test.log that's residing on C drive. You can also use PowerShell. So aside from using script brackets, you could use PowerShell brackets and call PowerShell. So any command that you want to run in PowerShell can actually be run as a user data script, right? So the example over here is we're reading an S3 object. We're looking at a specific bucket, so we're calling the bucket name. The key is actually the object that is stored within the bucket, and the file is the destination file that's where it's actually going to get stored. So using that, you can actually copy a file out of S3 as well and store it locally. You might be questioning why you'd want to do this. So there are a whole host of reasons why. The first one, of course, is security. Your instances get locked down by default because you have full control of the instance. You know exactly what software is being installed, and you actually don't need to access it via keys because you know exactly what data is running on it. The next one is automation. So again, because you understand exactly what is being run on that instance and it's not being done manually, there are probably less mistakes that will happen with this platform. From an availability perspective, you can drive higher availability with the self-healing aspect of autoscaling as well. From an efficiency perspective, you can audit and manage your estate with less time and effort. Obviously, from a scale perspective, you can manage a larger scale deployment and drive autoscaling. And it's extremely flexible. You can choose whichever platform you want for your bootstrapping. So you can use Shell, PowerShell, CloudFormation, Chef, Puppet, or OpsWorks. And there are a whole host of others as well. Some quick do's and don'ts. Do use IAM roles. I haven't mentioned this before, but an IAM role, for those of you that don't know, is basically a role that can be assigned to an EC2 instance to provide it access to any other AWS resources that it might require. This is very important because then you don't have to actually put a secret key and a private key on the EC2 instance, therefore keeping your security extremely high and making sure that only the EC2 instance has access to those resources. If you're happy with your code and you're pretty comfortable with the way it's set up, go keyless. You don't need to log into your production web servers or your production application servers if you understand that the code is going to run smoothly. So there's no reason to log in because you can actually define your policies to actually grab the logs as it gets terminated as well. And the last bit is strike a balance between creating a golden AMI and dynamic bootstrapping. Basically over here what I'm trying to say is with an AMI, you can set a golden image, right? So you can install the basic software that you want to use, be it Apache, PHP, Node.js, whatever it is. Do install that software before creating the or using a base AMI. With bootstrapping, what you should be doing is really looking at the latest version of your code and pulling that into the platform so that it's always available to you. Don't install the base software and then install your code on top of that. It's just going to take more time for it to come online. From a don't perspective, don't put your API keys into code. It's not a good practice. Use IAM roles in its place. And don't bake it into your AMIs either. The moment you start baking it into the AMIs and by mistake, if you were to share it, that could expose your entire platform for anyone to use. So it's highly not recommended. Okay, so at this point, I'd like to do a quick auto-scaling demo. And what I'll do right now is I will break into my, hopefully you can see this. Yeah, okay. So I'm looking at my browser right now. So this is a very familiar console for most people, and I will actually do the demo through the console. So what we're doing right now is we're actually going into the EC2 part of our console. Right at the bottom, you will notice that we have auto-scaling available. So we're going to click on Launch Configurations first. And just so you know, I've actually already pre-baked this, but I will actually go through the steps of creating a new group so you see the steps that are involved. So the first thing that we're going to do is we're going to create a launch configuration. Right? We're going to choose a specific AMI that we want to use. And as you can see over here, you have a whole host of AMIs to choose from. I'm going to choose this particular Amazon Linux AMI. We're going to choose the smallest instance type to launch. Right. Over here, you can configure a whole host of different things. So the name of the launch configuration. So just going to call it launch configuration demo. You can request spot instances if you'd like. If you want to just use normal on-demand instances, you can use those as well. You can define an IAM role if you want to your particular use case. And you can define detailed monitoring. I highly recommend using detailed monitoring whenever you're using auto-scaling, because with detailed monitoring, you get 1-minute intervals to your metrics. With standard or free monitoring, you get them in 5-minute intervals. The next bit is a few advanced details. So you can define the kernel ID, the RAM disk ID, and then you can also define user data over here. So for the user data, I'm actually just going to quickly copy it from the other launch configuration I already have running. Just bear with me for a moment. So I already have some user data over here, which basically what it does is it's going to install Apache, it's going to install PHP, it's going to install the AWS command line, and it's going to install Git. Post that, it's going to clone a specific Git repository, which will create a PHP page. It will then start Apache, and then obviously we want Apache to start every time the server comes online. The next one is if you're running in a VPC and you want to assign a public IP address to those particular instances, you can do that. Or you can have it not have a public IP address. It really depends upon where in your stack you want this instance to be launched. The next bit would be to install storage. So by default, it's got a root drive. You can add more volumes if you need to, or you can reduce the size or increase the size based upon your requirement. The next bit is to configure a security group. Now I mentioned security groups are basically firewalls that you would use to define what you have access to. So by default, we enable it to have SSH to which is port 22, open to anywhere. I would definitely look to reduce that. And you can add a rule, which is to add HTTP access, which you want to have for a web server, right? Right, so then we're going to review this. We're going to see everything that we just defined. And then we're going to create a launch configuration. The next bit is if you need a key pair, you can assign a key pair. For this particular use case, I don't think I need a key pair because I know exactly what's going to be launched. And then I'm going to create the launch configuration. So basically what I'm doing here is I'm saying I don't need to log into these servers ever. I'm okay with them starting and terminating. Right. Now that we have this particular launch configuration created, we're now going to create an auto-scaling group. Excuse me. So the first thing is you're going to need a group name. So we're going to call this auto-scaling group demo. You can define how many instances you want to start with, and you can say where you want to launch this. So you can launch it into a VPC or into EC2 Classic. You can define the availability zones, like I mentioned. If you want to just launch it into one, you can launch it into one. If you want to launch it into both, you can define that as well. If you want to enable a load balancer on this, you can just select retrieve traffic from the load balancer. You can define which load balancer you want to use over there. And then you can do a health check depending upon which way you want to look at it. So you can do an ELB-based health check, or you can do an EC2-based health check. You can define the grace period between the health checks. So at this point, it's set to 5 minutes. and you can enable CloudWatch detail monitoring over here. The next bit is to define the scaling policy. So if you want to just keep it at a base level, you can do that. But if you want to change the capacity, we can set it to scale between 1 and 10 instances as an example. And then you need to define alarms. So the first thing is, when do you actually scale out? So you want to add an alarm for that. You can define an average of CPU utilization is greater than a specific percentage. So we can say, let's say we put it to 50% as an example, and it stays there for a consecutive periods of 5 minutes. You can create that as one of your alarms. So this basically at this point in time, if it stays above 50% or equal to 50% for 5 minutes, we'll raise an alarm. Now, based on that alarm, we're going to do an action. We're going to add 1 instance or 2 instances to the platform. And then, like I mentioned, we have a cooldown period. So the default is 300 seconds. You can define it to whatever you want after that. So let's say we want to set it to 10 minutes. We can do that as well. Obviously, from that point, you want to have a decreased group size, right? So you want to define an alarm for that. So over here, we want to have anything that is less than or equal to 20% as an example. And if it stays there for 1 consecutive period, we'd reduce the alarm as well. Oh, sorry, we'd reduce the number of servers running. So I'm going to remove 1 server from this particular autoscaling group. We're also going to wait 300 seconds for that before the next activity. The next one is to configure notifications. So over here, excuse me, you can add a notification to basically tell you whenever an instance is launched, terminated, failed to launch, or failed to terminate. You can then configure tags. So if you want to name your instances that launch, you can actually set them up. So over here, I'm just saying ASG demo are the instances that will launch. You can review this, and then you can create the autoscaling group. So now what we should see when we actually go back to the EC2 console is we should actually see EC2 instances launching. Right, so it's successful. If we go back to the instances, what we should see are EC2 instances shown slowly coming online. So as you can see, there's, sorry, this is the wrong bit. This is the one we want to look at. So I've actually already pre-baked this demo so that we can actually see a scaling policy at work rather than waiting for instances to launch. I have a colleague of mine actually, there you go, there's a fair amount of instances that have actually already launched. But you will, basically what you can see over here is this is the PHP page that would have been created by the instance. And if I refresh it every 2 seconds, what you'll start seeing is that it's moving through all the instances. Now the data that's being pulled here is actually the instance metadata, and we're just displaying it in a page. So each instance is querying itself to see exactly what the public IPv4 address is, the local host name, the local IPv4 address is as well. Going back to the console, as you can see, this is launching a whole host, but you can see over here, there's also ASG demo 1, which we just created as well. So ASG test was something I created earlier. My colleague had already started deploying some load to these platforms, so we already saw a large scale out. In fact, if I refresh again, we should soon see another scale out. Bear in mind, the scale out policy I defined for ASG test was extremely aggressive. So the moment there was any load on the platform, we'd actually see this. This was just for the test. We could show it to you in the demo. So what we should see is if we look at any of these instance IDs or if we look at any of these public DNS names, you should see them showing up over here. So this particular one is I233EE0EE. At some point in the rotation, we should see that showing up. There it is. It just shows up for you and then it rotates to the next one. So you can see load balancing is working over here. You can see that it's actually scaled out and it's basically handling the load that's being defined to this particular platform. Eventually there will be more that come online as these instances get added to the load balancer and basically this is how we would handle the load from here on in. So I've just got a couple more slides for you to see. So just a few best practices. So autoscaling isn't one size fits all. The most important thing is to choose the right metric. If you chose CPU utilization, you need to know if that's actually the right one for you. Is it queue depth? Is it the number of concurrent users? Make that choice for yourself or for your application. Don't just go with one metric. The next one is not to scale too aggressively. Just so you know, if you over-provision, that's going to increase your costs. The way that Amazon Web Services charges is by the hour. So if you turn on an instance even for a minute, you're going to get charged for that first hour. So please do not over-provision your platform. The other thing that can happen is you get bounciness with that, right? So you add more than you actually need, and you have to partially scale back shortly after scaling up. This is going to increase costs. Like I said, it's going to charge you for that first hour. Don't scale too timidly either. You're going to get poor performance because you're not going to be able to meet your loads, your load requirement, and you could potentially have outages due to a lack of capacity. So the best way is to really look at something in the middle. A scale out early and a scale in slow strategy is usually what we recommend to our customers, and I would highly recommend that you look at the metrics and then based upon that scale out early and then scale back in slowly. From what's new on the platform, so I mentioned this in the talk. You can attach and detach instances from autoscaling groups now directly. So if you already have an instance running and you want to use that as the base EC2 instance, you can do so by attaching it to the autoscaling group. You can place instances into standby states to troubleshoot. So if you have an instance that hasn't come online completely, you can actually have it move out of the autoscaling group but put it into a standby state so you can actually log in and troubleshoot it. You can hold instances in a pending state for installing software or retrieving logs at the end of its use case. This is really, really handy. This means that you can bootstrap early before it actually comes into the platform, and then when it leaves, you can get logs about exactly who accessed the platform as well. And you can create an autoscaling group or a launch configuration based on a running instance now. So you can, like I said, attach or detach, but you can also create the group based on a running instance. And with that, that's basically all I have. I'd like to actually point out that we have a lot of training that you can take beyond this. Obviously, we have online labs and training available. There are instructor-led classes in a lot of locations as well. And on top of that, we have AWS certification for you as well. So at this point, I'd like to take a couple of questions because we have a little bit of time. So the first one is, Scott. Is it possible to start an autoscaling group with a preference of 0 and add one instance on a schedule? Have alarms add, remove instances based upon network request volume, and then shut down all the instances? It is possible to add instances with a preference of 0 and add one instance, absolutely. But the alarm you define should be in line with that. So the question I would always have is, where are the network requests going if you have no instances running? So you really need to make sure that you're choosing the right metric and you're choosing the right amount of instances running at all given points in time. So with this particular use case, if you have network request volume, I would urge you to have at least one instance running. What is the difference between using user data while entering a launch configuration and bootstrapping? So basically bootstrapping would be where you add the user data, right? So the only place to add the user data is within the launch configuration. So you can define any script you wanted to within that launch configuration. You can use bootstrapping to just launch an EC2 instance as well. You have the ability to add user data to that one instance as well. So there's no difference. They're two different concepts altogether. Can you retrieve logs from instance on termination? So if the instance is already terminated, unfortunately, if you've also told it to remove the EBS volumes, you've lost all the data. So this is really where it's important to have a defined state where you can move the data out of the instance before it completely terminates. Another one is, so there's a question which says, is that a new feature to install AWS CLI through Yum? I thought it was only available through pip. So with our Amazon EC2 instances, we actually allow with our repository for the CLI to be installed through that. So if I choose to use a gold AMI to build a new instance from, is the attached instance storage automatically copied to the new instance? So there's two ways of looking at that particular question. The first question is, when you talk about instance storage, are you talking about the instance store or the actual data that's on the instance store? If you've got it enabled, it should copy with the new instance. If you define your AMI to have multiple EBS volumes, absolutely it would copy over as well. It's all about configuring the AMI that you define. Is it possible to add an M3 and a large instance to the same autoscaling group? So I'm a little confused at that question, because an M3 could be an instance family, and a large is one of the different sizes of that particular family. So maybe if you mean an M3 and a C3 in the same autoscaling group, then no, because that's the launch configuration. But you can have multiple launch configurations and autoscaling groups for the same load balancer. And that can basically mean that you can have different settings in each of them, and based upon different metrics, you can scale out each of those different autoscaling groups. Can you have an autoscaling alert based on how long a guest has been running? Can you use multiple alerts or combinations of alerts? So absolutely, like I just mentioned, you can use as many alerts as you want, and you can send whichever metric you want back to CloudWatch to use as the alarm. Are you providing the PHP page used in the demo to query the AMI data? So that's actually quite funny. So that PHP page is actually on GitHub. You can just Google it. Just search for PHP metadata, and it's on GitHub. I can actually just bring it back up really quickly so you can see it. There you are. So there's a source right here. So it's available to you guys at AlphaMusk Development. It's something I found yesterday. So yeah, just go to github.com/alphamusk and you'll find it over there. It's open source. So there are some older ones that have been answered. Is there a way to auto-deploy the application on each of the instances of autoscaling groups? So you can consider Elastic Beanstalk or Opsworks for this. This basically allows you to auto-deploy the application and in an easy form. You can also preview the new. We have in preview a new service called Code Deploy, which solves this exact problem of code deployment. So Code Deploy will be announced for full use shortly. It's on the platform for preview, so you can sign up for that if you want as well. Are there security mechanisms that allow mobile client upload directly to S3 with best security? This isn't really based to autoscaling, but actually there are. So you can use what we call our tokening service to actually give temporary credentials to a mobile client to upload to the platform. So absolutely, you can do that as well. Can we include tags to be added for the new instance? So absolutely. So if you look at the console, I've actually added a tag to each of these instances that have been launched. And you can see that they come online with the instance. So actually, if you noticed before, it was set to 8, and now it's 11. So one of my autoscaling groups has actually hit its maximum. But you can absolutely set your tags to it. I've only defined name. If you have more tags that you want to define, absolutely, you can just define them there. So I think you mentioned that an action you could take on an instance scale out was to notify the load balancer. Can you describe how that occurs? Sure. So that's actually something that we like to call, it's actually a back-end process. You can define the load balancer that you want to have as part of an autoscaling group. So when you have that, any instance that comes online from that autoscaling group will be automatically attached to the load balancer. And it will come online as soon as it does. There are different health checks for the load balancer. The load balancer will ensure that the instance is responding on the correct port or on, with the correct HTTP page for a health check, and then bring it back into rotation for any further queries to hit that instance. is there a limit of instances a single load balancer can handle? So actually there isn't an upper limit. It really depends upon how many instances you want behind it. So the load balancer also has its own auto-scaling policies, and that will be handled by us, and will be scaling out to handle the load of requests coming through it as well. Is the instance created in autoscaling the same as the instance created by launch more like this now? Generally, I launch instances by launch more like this, and then create new volumes from the snapshot of the original volume, and then attach the new volume. Okay, so basically, yes, it is very similar to that. It launches more like this. So if you create an AMI of that particular image, you can then use autoscaling to then launch that image beyond the point it's at right now. So you can do exactly what I did. If you don't need to use user data, don't use it. Just launch more instances using a metric that you define. It could be a schedule as well. How about hybrid systems with non-EC2 instances? How does autoscaling run as a best practice? That's a very interesting question. It really depends what your backend is. If you want the platform to handle those as well, it's not going to be able to launch instances because it's really based around being able to launch more EC2 instances. CloudWatch, however, can raise alarms for you if you send metrics to it. So if you want to watch what your hybrid backend is doing and based upon that launch EC2 instances, absolutely you can. Right, so let's say you have your core web application running on premises, and you have a link into Amazon Web Services, and you only want to have spillover be handled by Amazon Web Services. You can absolutely do that. So you could say define a CloudWatch metric that watches your on-premises platform. You define an alarm that talks to an autoscaling group that only comes online if and when the on-premises location is out of capacity or reaching close to capacity. How can we keep the same public IP address assigned to it even though the instance restarts? So this is something that may be a little hard, but you can actually define a pool of IP addresses in your user data. It's not very straightforward, but please do realize that when you're using load balancing and you're using autoscaling, you shouldn't really have to worry about which IP address it's going to, because you should be just hitting the load balancer, which has a CNAME that you can attach to your website. Is there any way to scale up and down based on server farm response time? So absolutely. So whichever metric that you choose to use, you can use it. You can just define what you want and then scale in and out based upon that. And the next question is, how do we scale out vertically? So those are two different terminologies really. Scaling out is one thing and scaling vertically is another. So if you wanted to scale out vertically, I'm assuming you want to have different servers being launched or instance sizes being launched. We kind of covered that off in the other question, which is basically have multiple autoscaling groups with different sized instances defined in the launch configuration. How do I scale based on concurrent users, as this is not a server metric? Right, so basically what you'd have to do is you'd have to send these metrics from your EC2 instances to CloudWatch. They're usually defined within the server. You can see how many concurrent users you have, and then using that as a metric, you can raise an alarm and you can scale based upon that. Okay, so we have time for one more question. Let's see if there's anything else. Can we provide some CloudFormation examples which have autoscaling and deploy the code in it? So what I'll probably do for that one is I don't have that in this particular demo. I will, however, share that with whoever likes to would like that. I'll provide an answer offline for that particular question. Is there a record or a log somewhere of how many instances were created or decommissioned over time? So absolutely. So within the autoscaling groups in the console, you can see that there's actually a history of what's happened with that particular autoscaling group. So if you look at, let's say, the one that we launched earlier, so there's a scaling history over here which will actually tell you what's happened at any given point in time. So you can see over here, it successfully launched more instances based upon the autoscaling policy. Earlier in the day, I had them terminating as well. So you get an entire history of exactly what's happened with that platform. All right, with that, I just have one more slide to show you guys. And this is just to reiterate the point earlier that Christoph had brought up. Thank you so much for attending the AWS APAC webinar week. We hope you found it helpful and interesting. And please do complete the survey and tell us your thoughts about today's webinar. With that, I'm going to hand it back to Chris. That's it. Okay, so thank you so much. And hopefully you'll join the next webinar as well.